Okay, so what I'm going to do today is just to add the knowledge that we have there, okay, in Chem. So this is a different material, but the same focus as the one in your manual or modules at saka doon sa recorded slide ko. Okay? And later on, I think we're not going to finish the whole 90 minutes. Okay? We're just going to tackle some of the topic that we have at least in module 1. So we start with, we could say, the nature of life. Okay? So it has been established as early as the 17th to 18th century that light is a wave. Okay? And whenever you have a wave that's, we could say, vibrating disturbance to which energy can be transmitted. Okay? So pag sinasabi nating wave, you can observe it, there's a water that stands still and then you add something to it and you will see maybe top view. Okay, the wave would look like this. So pag meron kang inadloon, so merong disturbance na makikita mo. And if you're going to make it like top view here, we're going to have side view. This is how it looks like. Okay? And similar din to, I don't know if you watch some NCAA or UAAP na laro, di ba yung mga fans, wave! Okay? So, whenever there's a wave, there's, we could say, two ways to characterize it. Okay? The length and the amplitude. So, ito yung length niya. Okay? So, when we're talking about wavelength, this is just the length of two consecutive points of a wave. So, pwedeng yung peak, which is the highest point, or yung trough, or at any point as long as they're consecutive. Okay? So, wavelet is just the distance between identical points on successive wave. Now, amplitude, on the other hand, that's just the height from the midpoint. Okay? So that's the vertical distance from the midline of a wave to the peak or trough. Peak is yung highest point, trough yung lowest point. Okay? So if you're going to what we call look at the materials that we have here, whenever we talk about wave, okay, we can distinguish also the property of a wave by how many times you could see a wave in a given point in time. Yun yung tinatawag nating frequency. Okay, the number of waves that pass through a particular point in 1 second. So we could say cycles per second. So it can be like this, or like this, or that's just hertz, the unit of this what we call frequency. Okay? So if we're going to look at this, we could say that the relationship between the wavelength and frequency, they're not the same. I mean, they are inversely proportional. So the longer the wave, the lower the frequency, the shorter the wavelength, okay, the higher is the frequency. And if you're going to combine wavelength and frequency, what do you have? If you multiply wavelength with the frequency you have, anyone? Okay, you have the speed of light. You can get the what we call yeah, you can have a screenshot if you want. And anyway, I'm going to make this available in YouTube. Okay, so whenever you have the frequency and the wavelength, you have what we call the speed of the wave. Okay, and later on you will know the value of this. Okay, now most of the wave-like properties that we have, okay, we got it from the so-called radiation. Maybe before I use this thing. So when we're talking about radiation, this is the energy transmitted through space in what we call the form of the waves. And the light as we know it, okay, it's made of, they said, of an electromagnetic waves. That's what James Clerk Maxwell proposed, that whenever you have a light, it has an electric field component and a magnetic field component. That's why you call it electromagnetic waves. Like, so this is the magnetic field. So this is what we call the electric field. Okay. And as I've told you, whenever we have wave, we deal with this radiation. And what we have here is an electromagnetic radiation. So this is just the emission and transmission of energy in the form of electromagnetic waves. And then again, when we're talking about the speed of light in vacuum, it has a value that's around 3.00 times 10 to the 8 meters per second. And all magnetic radiation, we could say, as we have discussed earlier, it's just the sum, or not the sum, the product, okay, of frequency times the wavelength. Now, if you're going to look at the electromagnetic radiation spectrum, it's a wide field, okay? From this going to this, and the visible region that allow us to see the different colors around us, it's a very small region. But if you're going to look at the relationship that we have here with respect to the electromagnetic radiation spectrum, we can describe it in terms of the wavelength. So here we have what? The longer wavelength. And here we have the shorter wavelength. So as you could see here, okay, if you have the longer wavelength, you have lower frequency. Now here, if you have what we call the shorter wavelength, you have the higher frequency. Now, how are we going to relate this with respect to energy? So maybe the best thing that we're going to do it is this one, the visible region. What do you call this? Naano nyo na ba yung Roy Chipip? So you can ask the question, which color has the longest wavelength? Which color has the shortest wavelength? Now, what is the relationship of wavelength with energy? Or what is the relationship of frequency with energy? Which is warmer, hot or yellow? Or blue or yellow? Anyone? Alin yung mas mainit, yung blue flame or yung yellow flame?
Blue po.
Okay.
Blue po.
It's the blue. Okay, although they said cool blue. Have you watched Game of Thrones, the last season, where the two dragons fought with one another? The normal dragon emit what? Yellow flame. The dragon that was resurrected by the Ice King emits blue flame. So between the two, we could say warmer you blue flame. So what does that mean? Okay, the one that has the longer wavelength, usually they have what? Lower energy. And the one that has the shorter wavelength, it has higher energy. What's the reason why you don't look directly to the sun unless you're the president of the United States who's dumb enough to look directly in the sun during eclipse, the former president? Okay, most likely it will destroy you because you have what? What's the one you have in the sun? The ultraviolet. If you're exposed to ultraviolet, what do you have? Especially yung mga nag-beach, you get sunburn. If the tanning that you have, the tan that you want, it's too much, okay, you get sunburn because that is high energy. And if you're going to look at the different electromagnetic radiation, they have a lot of application, okay? From the so-called short waves radio okay, to what we call the gamma rays. So these are longer wavelength. As you go here, they are what? Shorter wavelength and they're more energetic. So X-ray is high energetic. As much as possible, you want to be exposed to it. Once a year, I think, gamma rays, you're not going to turn into the Hulk, you will die. If you go further here, there's a cosmic rays here, you will not go what we call, you will not become the Fantastic Four, you're going to become the Dead Four. Okay, because of the high energy that is going to be emitted. Okay, so there's a lot of questions that can be asked here. So the take-home message that you have here is you have to relate wavelength with respect to energy, with respect to frequency. So there's an indirect relationship between the frequency and the energy, okay, or the wavelength and the energy. There's an indirect relation between the wavelength and the frequency. And I would say there's a direct relationship between the energy and the frequency. And you will see it later on when we go to the equation. Okay. So we can have problem solving here, but I'm not going to do it in your quiz today. The quiz that you have today is, you could say easy. It's just a true or false 3 question that you have to do in 5 minutes. Okay. So let's try to solve some problem here. A photon has a frequency of 6.0 times 10 to the 4 hertz. So you're asked to convert this frequency into wavelength, which is nanometer. Does this frequency fall in the visible region? So the visible region, we could say, if you're going to look here, that's around 400 to 700 nanometer. So maybe we can start with C equals to frequency times wavelength. So what is being asked? You're being asked with the wavelength. So with that, 3.0 times 10 to the 8 meters per second over 6.0 times 10 to the 4 hertz. So if you're going to do that, this is equals to what? 5 times 10 to the, anyone? Kung kaya gutom na ako, antok na. 5.0 times 10 to the negative 3 or 3. But this is in meter, right? So if you're going to multiply it with nanometer, what we're going to do, if you're going to what we call multiply it with 1 times 10 to the 9 over 1 nanometer over meter. So that's 5.0 times 10 to the 12. So it's way beyond the visible region, because the visible region is 400 to 700 nanometer. Question. Kayang-kaya nito, ano? And of course, the question in the exam may not be like this. Okay? Now, the knowledge of this, what we call wave nature of light has been established, as I've told you, by early 17th, 18th century Christian Huygens. And this knowledge is helpful to look at the atomic structure or the electronic structure of the atom. So let's sort of review how the atomic models develop through time. So when was the concept of the atom first formulated? Way back when? The time of the Greeks. So there's a guy of Democritus, it says that if you keep dividing any material, there will become a time that you cannot divide it or you will become indivisible. And the word atomos was known, right? In some book, it says there's a guy, Democritus and Lucippus, the relationship that they have is just like a master and an apprentice of the Star Wars world. But what's happened? Since there's a guy by the name of Aristotle, who is more popular, the concept by Democritus was not known. Okay? Kahit noon pa man, basta popular ka, usually maniniwala sa'yo kahit BO-BO ka. Okay? So what is Aristotle's concept of an atom or an element? So he says all materials around the world is made up of what? 4 elements. And what's that 4 elements? One of them is the name of the one, right? Earth, wind, and fire. So what's that? Earth, wind, and fire. What's the 4th one? The 4th element that is what we call depicted in the Avatar, the last Airbender. Okay, and that was the concept that was accepted because Aristotle is more popular. Okay, until in the 1800s, an English school teacher by the name of John Dalton resurrected the idea of the atom, that all materials, the basic unit that they have is an atom, and it's different from one element to another. So he developed some postulates. Okay. Now, some years later, a guy named by Thomson finds some subatomic particles in this atom. So using a device, similar yung cathode ray tube na makikita nyo sa lumang TV, I don't know if you experience it, yung mga malalaking TV, lahat kasi ng TV ngayon yung flat, noon merong malaki. Okay? So he found the negative component of the atom, okay, that will end up to be electron. And from then, he developed the so-called plum pudding model, wherein he said that an atom is made up of what? Negatively charged, and he assumed that the positive charge is attached to the negatively charged. So it's just like a pudding with resins that act as the electron. Okay? But what happened? Several years later, one of the students by the name of what? Rutherford proposed his own model based on the experiment that we have. So the difference before, yung time ng mga Greeks is all speculations. There's no evidence. Dalton, more speculation, but at least there's some evidence. Okay, but it's Thomson and Rutherford who gave the scientific basis. Rutherford is a student of Thomson. So what he did what? The alpha scattering experiment. So he said, if the atom is indeed the plum pudding model, the alpha ray will just pass through, or it could be deflected all the time because there's some positive thing there. But he was surprised that based on the experiment, it just passed through. Okay. The only thing that happened is it hit something massive at the middle. So if it's a plum pudding model, merong deflection at all direction. Okay? Kasi nakascattered yung positively charged. But he was surprised that almost all passed through. Okay? So he developed his own what? Nuclear model. So that's the thing that they have before. If it cannot be explained, you develop a new theory and back it up. Okay? Now, during that time, the physics cannot explain the behavior of the nuclear model. Ano yung physics nila during that time? Are you familiar with the classical physics? Sino ang may dahilan kung bakit tayo may classical physics? Anyone? A person who was born December 25. Hindi siya si Jesus, okay? A person who was born December 25 and revolutionized the world, and it's not Jesus. Sino siya? Anyone? It's Isaac Newton. Now, during that time, the Newtonian physics cannot explain the behavior, okay, of Rutherford's atom. Okay, because if you're going to explain in terms of Newtonian or classical physics yung behavior ng Rutherford atom, dapat unstable siya. Okay? Because what happened, the electrons are usually what? In circle or elliptical orbits around the nucleus, and it must emit radiation. But consequently, they lose energy and spiral into the nucleus. Yun yung explanation ng classical physics, but it don't happen. Okay? Stable pa rin yung atom. Okay? So, to help them explain yung behavior na yun, there's need to be some scientific revolution during that time. And one that they have here, okay, is what we call, yung answer pala kanina, hindi siya kasama doon sa visible region, nandoon siya sa radio waves based on this one. Okay, so the answer comes here by Max Planck. Okay, sinold niya yung tinatawag na, anong phenomena yung sinold niya? Anyone?
Black body radiation.
Okay, sinold niya yung black body radiation, yung tinatawag nilang heated solids problem. Okay, so what he observed here, that when he heated solids, they emit electromagnetic radiation over a wide range of wavelength. However, yung radiant energy na ini-emit ng object, meron siyang tinatawag na lower limit. Kahit i-apply mo ng temperature, hindi nagbabago yung emission. Once na-meet yung lower limit, yun na yung kulay niya. So parang na-depict yung purpose ng wave. Kasi wave is some sort of a continuous. Okay? So, ang nangyari dito, naglagay siya ng explanation kung bakit gano'n yung behavior ng black body. Sabi niya, you have to treat the energy in the form of light as discrete units. So, yung amount na na-emit or na-absorb in discrete unit siya. Okay? O yung tinatawag niyang quantum. So, the way that he developed it is he developed this energy is equals to Planck constants times B. So, yung energy is just equals to the multiple of B or frequency. Okay? And this is really, we could say, a revolution during that time. Ito yung advent ng tinatawag nating quantum physics. Classical physics is only applicable to big objects. But once you go to subatomic world, hindi na siya nag-a-apply. If you watch my lecture, meron akong photo na pinakita ninyo denoting the boundary between the two. Okay? Now, this knowledge that he had was utilized by Einstein to solve the so-called photoelectric effect. So yung photoelectric effect, ito yung phenomena kung saan na-eject yung electron once. Okay? In-apply mo ng energy or light yung metal surface. So they cannot explain why at a certain energy ano yung electron na eject. Okay? And what Einstein do is he adopted what Planck constant. I mean, Max Planck developed. Okay? Ang tawag nga lang dito, instead of quantum, he call it a photon. Yung particle of light. So here, yung light ngayon, meron na tinatawag na particle nature. So dual nature of light. Okay? So the way that he look at it, nag-ano siya ng parang equation dito, that HB, which is just equals to what? Not kinetic energy. So it's equals to kinetic energy plus W, and W is the work function, and depends on how strongly electrons are held in the metal. So we could say the energy is dictated by the frequency. So the higher the frequency, the higher the energy. Kita niyo yung relationship? So pag tumaas yung frequency, tataas yung energy. What did Einstein got from this explanation? Anyone? Ano yung nakuha niya dito? Nakuha niya yung, anyone? The most prestigious award around the world that's going to be announced later this month.
Nobel Prize.
Okay, he won the Nobel Prize. He didn't won the Nobel Prize for E equals to mc squared. Okay, he won it for the explanation on the photoelectric effect. I don't know if you know it. Okay, pero maganda din yung explanation niya doon sa E equals to mc squared, and he regrets that. It's one of his biggest regrets. Okay. Now that we have the relationship between E equals to HB, and then what do we have? Speed of light equals to frequency times wavelength. So pareho itong dalawa. So that means we can relate what is now the relationship between energy and wavelength. So you see the frequency here. So frequency in terms of this one, so you just divide both sides by wavelength. So meron kang ganito. Right? So you replace it there. So E equals to HC over the wavelength. And you can use it to solve this problem. When copper is bombarded with high electron energies, X-rays are emitted. So calculate the energy in joules associated with the photons if the wavelength of the X-rays is 0.154 nanometer. So you can just look, you start here, and then you replace it with that, and then you replace it with the values, cancel all unit that can be canceled, and you get here a unit in energy. So we could say this is the dual nature of light. So the way I would interpret the dual nature, if you're going to look at the bigger, or we could say large object, you see a wave properties. But if you're going to look at smaller objects, subatomic particle, you observe a particle. And I think in my lecture doon sa recorded lecture na may link na binigay ko sa inyo, the classic example that I have there is the beach coastline. You see it as one wave, long wave. But if you're going to get closer, it's made up of sand. I think that's a classic example of this, what we call thing. Now, the next thing that I'm going to discuss to you is the phenomena that they observe. Why is it some element, most of the elements, when you hit them, they will only release certain line spectra. Hindi sila magpo-form ng rainbow. So what could be the explanation of this? So again, this support that light can behave as a particle. Okay? So for instance, hydrogen, so when they, what we call, you have a hydrogen lamp, you look at the spectroscope, so you see this thing being emitted. Okay? So Einstein proposed that, oh, that's the emission spectrum of the atom. Okay, so the emission is just the process wherein when an element absorbs energy, okay, it goes to a higher state, and then when it goes back to a lower state, it emits energy in the form of color. And most of the elements has that, like this. Okay. So how are we going to explain this line spectra? The Rutherford model cannot explain it. Okay. So we came into being to explain it. A guy by the name of Niels Bohr. Ano yung model ni Niels Bohr? Anong tawag dun sa atomic model niya? Anyone?
Bohr model po, sir.
It's called the planetary model. Okay? So ang depiction ni Niels Bohr no atomic model niya is parang yung mga planets na meron sa fixed orbits. So the way that he depicted there, okay? So merong orbits of different energy level at nandun yung mga electron. Okay? So what happened when the electron absorb energy, okay? It goes to a higher energy level, or an orbit of higher energy level. Now, yung difference, yung distance ng mga orbits na yon, it correlates to a certain energy. Okay? So what happened? The electron can only have specific or quantized energy value. So kapag nag-absorb yung electron ng energy, it goes to a much higher energy level na position. And unfortunately, this higher energy level, they are what? Unstable. Okay? So I think dito na ano yung concept na ground versus excited state. So if you go to the excited state, it has a higher energy level, the tendency for it is unstable. So when it goes back to the ground state, it's going to emit energy in the form of photon. Yun yung na-observe mong line spectra. Okay? Now, he said that light is emitted as electron moves from one energy level to a lower energy level. And he devised what we call an equation out of it. And if you're going to look at this, parang derivative lang siya ng ganito, right? Pinalitan lang niya yung frequency with 1 over n squared, n is the principal quantum number, and then yung Planck constant with the Rydberg constant. Okay? And if we're going to depict what's happening here, pwede natin sabihin, okay, so ito yung isang electron from this energy level going here. And then ito yung isang electron from this energy level going here. So between the two, which has a higher energy? Yung green o yung red? Ang daming ano, bakit itong green and red pa? Bakit hindi na lang pink? Yan yung tinatawag na unity. So, which one has the higher energy level? So, you have to look at is doon sa Roy G. Biv mo. Okay? So between green and red, green is the more energetic. And the explanation here, look at the difference here. It's so high. Compared sa difference dito. Mawawala na lang tayo, okay? Tapos mag-login na lang ulit tayo. Kasi less than 1 minute eh. I might send you a new Zoom link for next week using my other account sa school ko. Hindi ko alam kung bakit. So I hope to see the 27 of you in 2 minutes. And maybe you can prepare a question. Bigla na lang tayo mawawala. Less than 1 minute.